By using Newton's law of gravitational force and Newton's second law, as well as centrifugal acceleration, we can find the speed that is required to orbit a planet in a circular path. Mathematically, this is going to be what we're going to be targeting, orbital speeds for circular paths. And you'll have to be able to derive these equations, and they're incredibly easy to do. You're basically just saying net force equals ma, and since you're in a circle, a is v squared over r. The net force pulling on you is gravity, and since the force of gravity is g m planet m satellite over r squared, just simply set that equal to mass times centrifugal acceleration, and you can have everything cancel out and reduce down. So for example, mass of the satellites cancel out. All you're left with is the mass of the planet. The radiuses cancel out a little bit, and you can solve for v squared. Or, if looking at angular speed, you can apply the exact same kind of logic. Net force equals ma. Force of gravity is going to equal the mass times the centrifugal acceleration. Gm planet m satellite over r squared equals mass times centrifugal acceleration, which would be omega squared r. In this case, the r's don't cancel. They'll come across and become cubed. But the mass satellites do cancel out, and you can solve for omega. If you're at a different speed, you would not be able to maintain a stable orbit, or you would have an elliptical orbit. This requires more of a calculus perspective, so this is outside our scope. But you would be expected to be able to solve for something that's in a circular path.